Somewhere inside a cedar that was already old when Charlemagne was crowned, sealed in a single ring of wood grown in the year 774, there's a chemical scar left by something the sun did, something we have not once caught it doing in the 1200 years since. You could hold that ring in your hand. It weighs almost nothing. A sliver of dead tissue from a tree that has been gone for a millennium, and locked inside it is the fingerprint of a moment when our star reached across 93 million miles of vacuum and rewrote the chemistry of Earth's atmosphere in the span of a single year. Right now, as you're listening to this, that same star is hanging 93 million miles over your head, pouring the light onto your skin that lets you exist, and it has been behaving in a way that made NASA and the National Oceanic and Atmospheric Administration hold a press conference on October 15th, 2024, and tell the public in careful, deliberate language that the sun had crossed a line. The headlines took that announcement and turned it into something breathless. The reality underneath is stranger and far older than any headline could carry. So here is the promise I'm making you for the next 20 minutes. By the end, you're going to understand exactly what that ring of wood recorded in 774. You're going to understand why a nearly identical scar shows up again a little over 2 centuries later. And then again and again, scattered back across thousands of years like the ticking of a clock that nobody wound. You'll understand why the scientists who found these marks don't discuss them the way you'd expect people to discuss ancient history, with detachment. They discuss them the way you discuss a fault line under your house. And you'll understand why the single most important date in this entire story is one that has not been written yet. Keep that tree ring in your mind. We are going to come back to it, and when we do, it's going to mean something very different than it does right now. Let's start with a simpler question, because you can't appreciate what's strange about the sun until you understand how we can possibly know what it was doing before anyone was alive to watch it. We have telescopes now, we have spacecraft, but the telescope is barely 400 years old. Written sunspot records only stretch back a few centuries. So how does anyone claim to know what the sun was doing 8,000 years ago? The answer is that the sun has been keeping its own diary, and it's been writing it into the wood of trees and the ice of glaciers the entire time. Here's how the mechanism works, and it's genuinely elegant. Deep space is full of cosmic rays, high-energy particles screaming in from exploded stars across the galaxy. When they slam into nitrogen in our upper atmosphere, they transmute it into a radioactive form of carbon called carbon-14. That carbon gets absorbed into carbon dioxide, breathed in by plants, and laid down, ring by ring, in every tree that grows. Now here's the crucial part. The sun has a magnetic field, and it inflates that field out across the entire solar system like an invisible shield. When the sun is active and stormy, that shield is strong, and it deflects incoming cosmic rays, so less carbon-14 gets made. When the sun goes quiet, the shield weakens, cosmic rays pour in, and carbon-14 production spikes. Do you see what that means? Every tree ring is a snapshot of how strong the sun's magnetic field was in the year that ring grew. Count backward through the rings of ancient trees, some pulled from bogs, some recovered from the timbers of old buildings in England and Switzerland, and you can read the sun's mood year by year, deeper and deeper into the past. Carbon-14 has a half-life of about 5,700 years, so the signal survives for tens of thousands of years. The wood remembers. And in 2004, a team led by Sami Solanki at the Max Planck Institute in Germany did exactly that reading, and published a conclusion that landed like a shock. Writing in the journal Nature, they reconstructed the sun's activity across roughly the last 11,000 years, and they found that the second half of the 20th century, your grandparents' era, the age of television and moon landings, was one of the most magnetically active stretches the sun had experienced in about 8,000 years. Not the most active decade in living memory. The most active and longer than human civilization has kept records of anything at all. If you've made it this far, and you can feel the scale of what we're dealing with, a star that has moods lasting millennia, do me one small favor and subscribe. Not for me, for you. Because the story only gets stranger from here. And the payoff at the end is the kind of thing you'll want to have already been following. That's all. Back to it. Now, I have to be honest with you, because this is exactly the kind of claim that gets flattened into clickbait, and I refuse to do that to you. Solanki's grand maximum result was not the end of the argument. It was the start of one. Other researchers took the same tree rings and the same ice cores and pushed back hard. Some argued the 20th century sun was high but not unprecedented, that comparable levels showed up around the year 1200. The debate over precisely how exceptional the modern sun has been is real, and it is still not fully settled. But, and this is the part that survives every version of the argument, nobody disputes that the sun runs on cycles far longer and far wilder than the neat 11-year heartbeat we teach in school. The disagreement is about the exact ranking. The shared conclusion is that our star is capable of switching modes for centuries at a time in ways we are only beginning to read. And that shared conclusion is where the danger lives. But that wasn't even the strangest thing the Wood had to say. Before we get there, let's talk about that 11-year heartbeat, because you need it to understand what came next. The sun is not a solid ball. It's a churning sphere of plasma, and different parts of it rotate at different speeds. The equator whips around faster than the poles. That differential spinning wins the sun's magnetic field tighter and tighter, like twisting a rubber band, until it buckles. Where it buckles, it punches through the surface as sunspots, cooler, darker knots of concentrated magnetism. Roughly every 11 years, the tangle reaches a breaking point. The sun's magnetic poles actually flip. North becomes south, and the whole thing resets. Low activity, high activity, flip, repeat. We are living through the top of one of those cycles right now. Solar cycle 25, the 25th, since we started numbering them in 1755. And this is where the recent NASA announcement comes in, and where the sun made a lot of forecasters look foolish. Because the cycle before this one, solar cycle 24, was a dud. It was the weakest cycle in about 100 years. So when the experts convened to predict cycle 25, the consensus leaned toward another quiet one. Weak to average. Nothing to write home about. The sun did not cooperate. Activity ramped up faster and higher than the forecasts. On October 3rd, 2024, it fired off an X 9.0 flare, the most powerful of the entire cycle, the top tier of the classification scale. And a few months earlier, on the nights of May 10th and 11th, 2024, a cluster of enormous sunspots hurled a barrage of plasma at Earth that triggered the strongest geomagnetic storm to hit our planet in over 20 years, since the Halloween storms of 2003. People saw auroras that night in places that almost never see them, far south into the United States, across southern Europe, in skies where the northern lights are simply not supposed to appear. That's the storm behind the headlines. On October 15th, 2024, NASA and NOAA confirmed the sun had reached solar maximum, the peak of the cycle, and confirmed that its magnetic poles had begun to flip. That confirmation is real, and it's the honest kernel inside the sensational title. The sun did something it does roughly twice a decade, but it did it harder than almost anyone predicted after a decade of unusual quiet. Remember that pattern. Quiet, then a surge. The Wood remembers that pattern too, and it remembers it going very, very wrong. While all of this was unfolding, we did something no civilization before us has ever managed. We flew a machine into the sun's atmosphere. On December 24th, 2024, Christmas Eve, NASA's Parker Solar Probe, a spacecraft roughly the size of a small car, dove to within 3.8 million miles of the sun's surface. That sounds far. Let me give it to you in a way you can feel. If the distance from the Earth to the sun were the length of a football field, Parker crossed to within about 4 yards of the end zone. It did this while moving at 430,000 miles per hour, the fastest any human-built object has ever traveled, fast enough to cross from Washington, D.C. to Tokyo in under a minute. Behind a carbon shield, facing a corona that burns past 1,000,000 degrees Fahrenheit, its instruments sat at room temperature and took measurements from inside the atmosphere of a star. For 2 agonizing days after the dive, Mission Control heard nothing. The sun was between them and the spacecraft. Then, late on December 26th, a single beacon tone came back. It had survived. Parker has already overturned things we thought we understood. It found that the solar wind near the sun is threaded with sudden magnetic reversals, zigzag kinks its discoverers nicknamed switchbacks, which may hold the secret to why the sun's outer atmosphere is mysteriously hotter than its surface. But here's the humbling part, and it matters for where we're going. Parker can fly into the sun and measure it in exquisite detail, and it still cannot tell you what the sun is going to do next month. We can touch our star now, we still can't predict it. Hold on to that, because it's the hinge the whole story turns on. So let's go back into the Wood. Because the tree rings recorded more than just strong cycles and weak ones. They recorded the sun going silent, and they recorded it screaming. First, the silence. Between roughly 1645 and 1715, the sun did something that, if it happened today, would dominate every news cycle on Earth for a decade. It essentially stopped making sunspots. For about 70 years, astronomers who were by then watching carefully with telescopes recorded almost nothing, a nearly blank sun, cycle after cycle, the 11-year heartbeat flattening to a whisper. We call it the Maunder Minimum, and it happened to fall in the coldest depths of a period known as the Little Ice Age, when rivers that don't freeze froze, when growing seasons shortened and harvests failed across the northern hemisphere. Scientists still argue about how much of that cold the quiet sun actually caused versus volcanoes and natural variation. That link is genuinely debated, and I won't oversell it. But the silence itself is not in doubt. Our star can simply switch off its storms for the better part of a century, with no warning we know how to read in advance. And some researchers, watching the recent decline from that 20th century grand maximum, have quietly wondered whether the sun might be sliding toward another one of those long silences. Then cycle 25 came in roaring and complicated even that guess. We do not know. That's not me being coy. The honest state of the science is, we cannot yet predict when the sun will go quiet or when it will wake. But the silence is the gentle mystery. Now we come to the tree ring from the year 774, the one I asked you to keep in your mind, and this is where the story stops being about the past. In 2012, a researcher named Fusa Miyake, working at Nagoya University in Japan, was measuring carbon-14 in the rings of ancient Japanese cedar trees year by year. And in the ring for 774, she found something that should not have been possible. The carbon-14 level didn't drift. It didn't ramp up over decades the way solar cycles do. It jumped. A sharp, violent spike, a flood of freshly made carbon-14 crammed into a single year, roughly 20 times faster than the normal background variation. Something had bombarded Earth's atmosphere with an enormous pulse of high-energy particles in the space of about 12 months. And then it was gone. The mark was so strange that at first nobody could say what caused it. A supernova? A comet? The explanations flew. Then researchers went looking in other trees, on other continents, and found the exact same spike in the exact same year, in Europe and North America. This wasn't a local fluke. The entire planet's atmosphere had been hit at once. And when Miyake's team found a second one, a nearly identical spike in the year 9983, the leading explanation crystallized into something far more unsettling than a distant exploding star. The most likely culprit was the sun itself, a solar particle event so colossal that it dwarfs anything in the entire era of modern measurement. An eruption from our own star, an order of magnitude beyond the worst storms we have ever recorded with instruments. And once scientists knew what fingerprint to look for, they found more of them, buried deeper in the wood and the ice. A powerful event around 660 BCE. Older candidates near 5259 BCE, near 5410 BCE, reaching back over 7,000 years. Each one a year in which the sun appears to have lashed the Earth with a pulse of radiation so intense it left a permanent chemical watermark across the whole atmosphere of the planet. This is the payoff I promised you. That ring from 774 is not a curiosity from the deep past. It is a photograph of what our sun is capable of doing. A capability written into its nature, demonstrated over and over across the millennia, spaced out roughly on the order of once every 1,000 years or so, though not on any schedule we can trust. We have never witnessed one. Not Galileo, not any astronomer who ever lived with a telescope, not a single satellite. Everything we know about the sun's true upper limit, we learned from dead trees. The most powerful thing our star does, it has never done while we were watching. It has only left the receipts in the wood. Now hold that fact next to a second one, and you'll understand why researchers talk about these tree rings the way they do. The largest solar storm in recorded history that we did watch is called the Carrington event in September 1859, named for the astronomer Richard Carrington, who saw the flare that caused it. It was strong enough that telegraph systems, the entire high technology of the Victorian world, failed across Europe and North America. Sparks leapt from equipment. Some operators reported their lines kept working even after they disconnected the batteries, running on the current the storm itself induced in the wires. Auroras were seen near the equator. And here's the thing that should stop you cold. The Miyake events written into those tree rings appear to have been substantially larger than Carrington. Carrington is the worst we've measured. The wood suggests the sun has a gear well above it. In 1859, the damage was some fried telegraph wires because there was almost nothing electrical to break. We have since built a civilization whose entire nervous system is made of precisely the thing these storms destroy. Consider what actually happens when a great geomagnetic storm hits a modern grid. In March 1989, a storm far smaller than Carrington collapsed the entire Hydro-Quebec power grid in about 90 seconds, leaving millions without power in the cold for hours. In July 2012, a coronal mass ejection erupted from the sun that scientists later judged comparable to Carrington in strength, and it tore through the exact patch of space where Earth had been sitting only a week or so earlier. It crossed our orbit and hit nothing but empty space. A near miss most people never heard about. So picture a Miyake scale event, larger than Carrington, striking today. Transformers at the heart of national power grids, the massive ones that take months or years to build and replace, could be damaged in numbers we are not stocked to repair quickly. Satellites, drenched in radiation, could be blinded or killed, and with them the GPS that guides shipping, aviation, farming, and the timing signals that quietly synchronize financial systems and communications. This is the paradox I want you to feel in your gut. We spent a century building our world out of the one material the sun periodically incinerates. And we did it without ever having seen the sun at full strength, because the only evidence of that full strength was hidden inside trees, and we didn't learn to read it until a little over a decade ago. And here's the frontier. The part where honesty demands I tell you what we don't know, because the not knowing is the whole point. We cannot predict these events, not the small ones, not the giant ones. Solar Cycle 25 just demonstrated that we couldn't even correctly forecast whether an ordinary cycle would be strong or weak. The sun overshot the predictions in front of our best instruments and our sharpest minds. The physics of the sun's magnetic dynamo, the churning engine that decides when it storms and when it sleeps, is still not understood well enough to tell you what's coming years in advance. Parker Solar Probe can dive into the corona and touch the fire, and it still cannot warn you about a superflare with any meaningful lead time. The best we have, when a storm is already launched, is somewhere between 15 minutes and a few days of warning as the plasma crosses the gap to Earth. The date locked into this story, the one I told you at the start hadn't been written yet, is the date of the next one. The tree rings give us the rhythm. Roughly once a millennium, give or take, on no schedule we can count on. The last confirmed giant was over 1,000 years ago. We are not owed an exemption. Statistics don't work that way, and the sun keeps no promises. It could be centuries away. It could, in principle, have already happened this morning, and we simply won't know until the plasma arrives. No mission on the drawing board can close that gap soon, because you cannot forecast what you don't yet understand, and we do not yet understand the deep engine of our star. That's what the ring from 774 really is. It's not a record of something the sun used to be able to do. It's a record of something the sun can still do, and will do again, recorded in the only archive that was keeping watch when it happened. The wood remembered, so that 1,200 years later, we could finally learn to be afraid of the right thing. We began by trying to answer a small question. How do we know what the sun was doing before we were watching? And it led us here, to a star that keeps a diary in the rings of trees, that has moods lasting centuries, that can fall silent for 70 years or scream for a single one, and that has never once in all of recorded human history shown us its full power. We built telescopes to watch it and spacecraft to touch it, and the most important thing we've learned is the shape of our own ignorance, the exact size of the thing we cannot yet see coming. There's something almost humbling in that. For all our instruments, the deepest truth about the sun came to us from the patient, silent bookkeeping of trees that died 1,000 years before we were born. They were writing down the story the whole time. We just finally learned how to read. If you made it all the way here, you already know this channel is worth the notification bell. Turn it on, because the next chapter of this story writes itself every time the sun stirs. And I'm genuinely curious which piece landed hardest for you. So tell me in the comments. Was it the tree ring from the year 774? The discovery that the 20th century sun may have been the most active in 8,000 years? The 70-year silence of the Maunder Minimum, or Parker Solar Probe surviving its dive into the corona on Christmas Eve? Drop the one that got you. And if you know someone who still thinks of the sun as just the thing that comes up every morning, send them this. Because they, like the rest of us, are living under a star that is still keeping secrets, and still keeping its diary one ring at a time.